Hello, hello, hello. Welcome to everyone that is here on the YouTube channel. Today we are doing some LeetCode. And a couple things I want to talk about here. So what I've been doing is doing these questions on Reddit. I've been taking advantage of the Reddit public access network. However, I realized that since I'm a YouTube channel and I have access to YouTube Live, I may as well try to just do it and see how well it goes. So I think having to do LeetCode live like this is pretty cool for hopefully the viewer and also myself. I get to practice a lot because I'm having to force myself to talk about my own solutions and discuss trade-offs. I'm also put a little bit under pressure because people are actually watching the stream. And then I hope it benefits you because instead of me creating, there's a lot of resources out there that will teach you how to do a specific problem in the best way. And I think those are phenomenal when you're trying to study LeetCode. And I think you should probably also check those out too. But this is a little bit different where I'm not really going to be teaching you how to LeetCode. I may talk about I'm definitely going to be talking about my own thought processes. But this is really for you to feel like maybe you have a study buddy, someone that you can do these questions alongside. All these videos will be available after we go live. And you can also hear me struggle. You can watch the mistakes I make, and hopefully by the end we come up with some optimized algorithm that is going to really help drive the lesson home. So for anyone watching, if anyone's looking to start their LeetCode journey, I've been doing this for about 8 days now, and I've uploaded like every single stream I've done is available on my YouTube channel. So if you're looking from going to 0 questions done, or if you have a session going currently and you just want to reset it and start again, you can visit my YouTube channel and you'll see all the different, I'll show you right here. I'll show you all the different streams that I've created. So right over here, you can see that I have this LeetCode accountability stream number 1 start here. So just based on that, you can already start your journey there, and by the time you finish watching all these different videos, which normally are an hour, some of them are a little bit longer, you'll end up at that 55 question mark that we've accomplished so far. So I think it's all pretty cool. I hope you benefit from it. Without further ado, we're going to go ahead and resume from the last place that we left off in hopes that we can get some questions under our belt. So let's go to easy difficulty. I'm doing all the questions in order from easiest all the way to hardest. Eventually we will have gone through all the easies, all the mediums, all the hards. There's a lot of mileage you can get out of the easy questions. I wouldn't just discount them because you think, oh, they're easy questions, I'm not really going to learn a lot. Some of these questions are pretty difficult, and if you do them and really think about them, they'll definitely set you up for success. So let's start going here. I always sort by acceptance. Let's go all the way down to the one that we have next. So let's get to this one. I guess some new ones here popped up, which is pretty interesting. Okay, so given a string S consisting of lowercase English letters, we want to return the first letter to appear twice. If letter A appears twice before another letter B, okay, this is interesting. So the first one that appears twice is C, A, B, C, D, D. So I think we can just keep a hash table where we have the key being the letter and then the value being the frequency of that letter. And as soon as that frequency equals 2, we can just return the letter. I think that's something that's pretty standard. I think that'll be good. So let's go for it. So let's create const frequency. We'll create an object literal here. And then what we can do is now we can do for const C of S. So C here represents the character. We're essentially going to be going through every single character of our input string S. We can start incrementing. So we can say frequency of C equals frequency of C plus 1 or 1. This is a nice little JavaScript trick here. So the first time, if we haven't already seen C, we'll try to do frequency C plus 1, which will be undefined plus 1, which I guess it's not a number. But we can also check it out. Let's check it out here in the DevTools. If we do undefined plus 1, okay, that's not a number. And not a number is falsy, so then I'll go to the right-hand side, so I'll just set it equal to 1. And then the next time we try to add a 1, we'll get a real value, so we'll be able to do the addition there. And then here we can just say if frequency at C is equal to 2, then we can just return C. Now, is it guaranteed Let's guarantee that there's at least one repeated letter. So let me go ahead and run this, and let's see what we get. So we get C and C. Can do this. C and D, C and D. Now, I have a feeling, just based on other questions that I've seen, there might be a way for us to use a bit set here. Right? The first time that I try to mask, like if I use a mask and I toggle a bit, so if it's like already set, oh yeah, we can just use bits here. We can just, let's see, this is only lowercase English letters, right? So we want at least, yeah, I think we can just set, well, let's submit this and see if it succeeds. Okay, that's 100%, so that's really great. I mean, is there even a point to do it the other way? I think oh wow, 100% twice. So maybe there's not a point, if not this, at least just for practice. So let's see something. If I wanted to do it with the bit way, I can toggle a bit by using, if it's 0, 1, I can toggle it on by doing the OR. And if I AND it with 1 and it gives me the original number, then I know it's just this one. So let's say, maybe here we'll do let alphabet equals 0. For const C of S, I want to get the normalized code. So I can do const code equals C dot carcode at 0 minus 97. So this will tell me how many times to move that mask over. Right? So if I now do, I guess we first check to see if it's on, or we actually set it on. So here we should be able to do alphabet. We're going to or equal it with, let's do let mask equals 1. Mask by code. So if it's A, that's 0. We just shift it over by 0. If it's 1, we shift it over by 1. But we're not creating a new mask, we're just shifting it over every single time. And if I say here, if alphabet, let's see, if alphabet and mask by code. So if I do 7 and 1, we should just get alphabet. I think here we can do equals alphabet. And maybe here we can return C. So if I take my mask and I shift it, and then I do alphabet and that masks, if that equals the alphabet, then we should just be able to return C. So let's see what this does. Undefined and undefined. How is that? Oh, so we probably just didn't get. Let's think about this. Alphabet is 0. And the mask is, let's say, 1. So if alphabet, let's see, let's do mask code. So like for A, it's going to be 0. So we just leave it here, and then we OR it, so that becomes 1. Now we go to the next one, B. Let's say this is false. We just come here. We do mask, left code, shift it over. That becomes a 1 here, right? So then we have a 1 here. And we go to C, we go over here, so that gives a 1 here. And we say if alphabet and mask, do we get another C? That's 3. Mask of 1, 2. Oh, maybe I want to do code minus 1. But if it's 0 though, if it's 0, I want to keep it at 0. 1, 2. No, that's fine. C will do 1, 2. Yeah. So 1, 2, 0, 0. So we're going to do 1, 2, 4. Oh, that's just going to equal the mask, right? It's not going to equal, yeah, return C. A and undefined, so still not exactly what we wanted. Is it an issue with, check to see if it's on. So C.carcode at 0, minus 97 would be 2. We have our alphabet, which is now being constructed. Mask left of code, which is 2. So we're just shifting that over twice. Alphabet and this, so 1 and 0 is 0, 1 and 0 is 0, 1 and 1, so that's just going to give us 0, 0, 0, 1, 0, 0, which is equal to the mask. But there's, I guess there's something, I know we're so close, like this is, I know this is like a valid solution. Maybe I should do things in more steps. A and C undefined. Check to see if it's on. Mask and code. Let me see again. Left shift. Shift the first operand by the specified amount of digits. 2 if you shift it over by 2. Okay, so that seems right. And if I or equal mask and code, right? So if it's a 0, if it's 1, it'll stay as a 1. That's fine, because we would have already checked before if it's already set. If it's 0 and 1, a 1 will just always make it. Yeah, we'll always set it that way. Alphabet or equals 1 left shifted by 0. Okay. Check to see if it's on. Let's see. On mask equals mask code. So if alphabet and on mask, alphabet and on masks equals on mask, return C. C and D. Okay, so what is it that we were doing before? Oh, it's because, yeah, we weren't masking it the correct way. This is going to fail because, oh, still, oh, I guess those are just numbers. So still 100%, which is fantastic. That's very cool. I want to take a second here. I wonder if, like, well, we can talk about it later. Okay, cool. So that's one down. Let's get to our next one here. So, oh, the minimum time visiting all points is a tricky one. What I've been doing more recently is I have a list that I've been sort of generating on not Reddit, but LeetCode, where I do this thing called a weekly roundup. And at the end of every week, we look at some of the previous questions. This is one I'll probably save because this one's especially tricky. Or I'll just spend some time in it on my own, and then the next time I come back on stream or on live, we can revisit this. So let's look at the next one here. Maximum 69 number. You're given a positive integer num consisting only of digits 6 and 9. Return the maximum number you can get by changing at most 1 digit. So we always want to make the most significant bit the maximum number, if that makes sense. So if it's already a 9, go to the next one and change that one. So it's 9969, right? 9969. Here we just changed this one. So I think this one, maximum number you can get by changing at most 1 digit. So we can start picking off all the different. The only tricky thing here is that because it's backwards, or, okay, I know what we can do. We can start, okay, yeah, we can, let's create a num copy. Say this is num. And let's say max is equal to 0. So what we can do here, let's see, how do we want to do this? 9669. If I pull the 9 off, that's fine. If I pull the 6 off, do we add, oh, maybe that can be the multiplier. We can have like, let's do let max is 0 and let multiplier equals 1. Here we can say while num copy is not equal to 0, now I can start pulling things off. Well, let's say num copy is num max. Okay, so I always want to keep track of num, or we can just have like a temporary thing. Let's see what we do here. Let's first get the last one. So num copy equals num copy modulo 10. That will give us the last digit. Let's say const digit. Const digit is num copy modulo 10. If digit is equal to 6, we'll do something else. Here we can say num copy equals math.floor of num copy divided by 10. But a couple different things we want to add here. Multiplier should always go up, right? Multiplier times or equals 10. If it's equal to 6, like if that first one was 6, we can add a 3 times multiplier. If it's equal to 6, we can add a 3 times multiplier, which is 10. So we can say max equals math.max of num or num plus digit times multiplier. And then here we can return max. Let's see what this does. 10269. Okay, strange, crazy. So what was it that I was trying to do here? Like we pull off the first digit, so that's just a 9. If digit's equal to 6, we don't, like this is a 9, so we don't do anything, but we do increase our multiplier. So 1 times 10 is 10. Num copy now equals 9669. Const digit is num copy. If digit equals 6, which it does, max equals math.max of 9669 or 9669 plus 3 times multiplier, right? Because that's the differential. 3 times 30, 3 times 10 is 30. So 9669 plus 30 is 9699. And we can keep doing this over and over. Output 9969, expected 9969. We'll go over another couple of cases here. 9969, 9999, and 9999. Okay. It's better not to apply any change. So if we never got to, maybe the max should just be the number. 9999, 9999. Is that not what I got? 0, 0. Yeah, I think we should just 9969, 9999, 9999. Okay, sweet. So what did this do for us? 26.27. This will be a log n solution, right? Because we're having the space every time. Let me run through one of these again. 76.27. Let's see what discussion is. Replace once, one pass without converting to string. Beats 100% time and space. No strings. C equals 9. Well, they're making it a string. Replace once, integer parse int, okay. One pass without converting to string. All term divided by 6, 6 the largest digit. It seems like there's nothing here that I'm very, max p equals 10. Yeah, this was sort of like what I did here. I'm pretty happy with this solution. I understand there's plenty of ways to go about it, but I think that if you were to just to do this, I think that's probably fine. All right. Evaluate a Boolean binary tree. Okay, nice high quality question. That's awesome. So you're given the root of a full binary tree with the following properties. Leaf nodes have either the value 0 or 1, where 0 represents false and 1 represents true. Non-leaf nodes have either the value 2 or 3, where 2 represents the Boolean or and 3 represents the Boolean and. If the node is a leaf node, the evaluation is the value of the node. Otherwise, evaluates the node's two children and apply the Boolean operation of its value. with the condition. Oh, so it's or. So let's see, we're gonna go left, we just return true. Okay, down, if it's an and, it's 2 or 3. Okay, so leaf nodes have either the 0 or a 1, where 0 represents false and 1 represents true. Okay, so I think the base case could be, right, our base case here is already if root.val is equal to 0, or root.val is equal to 1, then I think we should just return true or, oh, I see, okay. But we shouldn't return, yeah, if root.val, let's do this, if root.val equals 0, return false. If root.val equals 1, return true. Else, we can return, yeah, we need to return the left and right children. So it would have to be return evaluate tree at root.left. So we get the value from there. Let's say we start here. This gives us left is here, or, okay, and then and. So maybe what we should do is get the value of the left and right. So say we come down here, we come here, it's not any one of these, so we get the left and the right. Left Boolean, right Boolean. So left Boolean here would be root.left, and here const right Boolean would be root.right. So by the time we get down here, like we come up here, let's say we start in the beginning, doesn't equal this, so we come here, return this. Now we have left Boolean of true, and now we go to right. Left Boolean is false, we come up here. Okay, so we return if root.val equals 2, return left Boolean or right Boolean, or return left Boolean and right Boolean. So let's see what this gives us. Sort of like a quick way of going about it, true and true, and then we have 0, so two very pretty simple test cases here. Let's run this and see what we get. 66.04. So it's really just going through exactly what the description says and doing that. So really what I used here was, I think this would be, I go to the children first, so it's a post order. Post order is very useful if you want, like, you want to get information from the children first and then evaluate it. So something that we could do here, like here we really could just return, I feel like we should just be able to return the value here, right? Root.val equals 1. Really here we can return root.val. And let's see if this works. If root.val, yeah, return root.val. True, false, true, false. 20.28. So the reason that still works is because 0 is considered falsy and 1 is considered truthy. I think it might be worth to be a little more explicit, because that way it's easier to read, I think, in the long term. Like a lot of engineers know that this is the case with truthy and falsy values, but being maybe a little more clear and explicit will help you in the long term. So yeah, we really just go through all this and we figure it out that way. We can also, I mean, this is more like a quality of life improvement. What we could also do is create like an object literal that maps to operations. So we can do var operations equals, let's say, it'd be nice if we can do true. Left nodes have either value 0 or 1. Now, can we do that? False. Oh, but how could we do 2 is and? Yeah, it'd be nice if I can say like here and 2. If root.value is operations or something like this. That's something that we could do too and just create. We don't really need to even do any of that. I think I might be able to just do this. False. And are these reserved keywords? I don't think so. Or is 3. So if root.val equals operations, it's something that you might want to do on your own, like operations.true. It might be kind of nice to implement because then it's just very easy to read. It's almost like creating your own enum, but I'm sort of going on a tangent here. So maximum product of 2 elements in an array. So given the array of integers nums, you will choose 2 different indices I and j of that array. Return the maximum value of nums I minus 1 times nums j minus 1. If you choose the indices I and 1 index, you'll get the maximum value. So to get the maximum value, we want to have the biggest difference between both numbers. That way it's not, like we want 2 of the smallest and 2 of the biggest. 2 nums.length, and it's a pair of 2 elements in the array. Yeah, we want 2 smallest, 2 of the smallest, and 2 of the largest. Why is this not playing nicely? 2 of the largest, right? So if we look at our array here, the 2 biggest are 5 and 4, and then 2 and 3. But we need to pair the biggest with the smallest and then sort of go down that way. 4 and 3 is 12. If you choose, oh, so do we just want, oh, not necessarily. Not necessarily. Given the array of integers nums, you'll choose 2 different indices I. Return the maximum value of nums I minus 1, nums j minus 1. It's not clear to me why that would be. No, we want, oh, maybe we just want the 2 middle ones, right? Because like if we had 1, 2, 3, 4, 5, 6, 7, 8, let's say. We don't want 8 and 1. We want 4 and 5, right? Now, will this always be, this is not always going to be, like if it was an even numbered one, like 1, 2, 3, 4, 5, and we go to the middle, we can go to the midpoint. Yeah, there's a couple different ways that we can do this. We can sort it first and then get to the midpoint. Yeah. Like this is even, so 0, 1, 2, 3, 4, 5, 6, 7, 8 divided by 2 is 4, 0, 1, 2, 3, 4. We would do 4 minus 2. Right? That would be the biggest. If it's an even, we do the middle. Yeah, so I'll start by sorting this. Maybe this is not the most effective way of doing this, but we can say const sorted nums equals a copy of nums dot sort a minus b. We can say if sorted nums dot length modulo 2 equals 0, right? Else, let's say let midpoint. So the midpoint is 8 divided, yeah, midpoint equals math.floor, or it'll always be the same, right? Math.floor of sorted nums dot length divided by 2. If it's even, like in this case, 0, 1, 2, 3, 4, then we should return we should return the sorted nums at midpoint times sorted nums at midpoint minus 1. And then if it's even, like 1, 2, 3, 4, 0, 1, 2, 3, 4, it's 5. 5 divided by 2 is 2.5. We go 0, 1, 2. So here we can just return sort of like the same thing, but here we'll add 1. And it's always going to be at least 2. So let's do it for, let's do 1 and 2 and also 1, 2, 3. So this is even, right? So midpoint is 1. We're going to return this. And then else if it's even or odd, we'll do 2 times 3. So I think this would work here. 12 and 12. Let's get all the example test cases. 12, 20, 21. Oh, did I not? Sorted nums, midpoint, sorted nums. That's very interesting. Maximum product of 2 elements in an array. Sorted nums. If this is an even array, so what are we getting for the other ones? Expected 12, 0, 1, 2, and 2 divided by 2 is 1. So we returned sorted nums at 1 times sorted nums at 0. But it wants 12. Oh, minus 1 of sorted nums I minus 1. Very interesting. That's so weird. Okay. So I guess minus 1. And we can always do let, instead of, we can say let first part equals sorted nums midpoint, since this will always be the same for both. And now here we can replace this, return first part times sorted nums at midpoint minus 1 minus 1. This should be in parentheses here. And similarly, this should be in parentheses. Now let's see what this gives us. 6, 12, 12, 12, 16, 12. We'll choose 2 different indices I and j in that array. Return the maximum value of nums at I minus 1 times nums at j minus 1. So let's see, if you choose the indices, so if this was 2, 3, 4, 5, we're gonna go to the, we're gonna do 2, 3, 4, 4, and 3. Right? I minus 1, minus 1, 3, 4, 5, 2 becomes 2, 3, 2, 3, 4, 5 is even. 4 divided by 2 is 2, so we're going to do 4 times 3. If you choose the indices I is 1 and I is 2, indexed from 0, you'll get 4 and 5. You will get the maximum value. So not, well, 4 and 3, that's so strange. Yeah, wait, why wouldn't it be, how did I even come up with that in the beginning? Wouldn't it just be the last 2? Yeah, wait a second, I don't even need the midpoint, right? Yeah, forget the midpoint. Why don't we just do let first part is sorted nums. It will always be the last 2. Yeah, there you go. I don't even need first part here. Whether it's even or odd, that doesn't even matter. We can return sorted nums at sorted nums dot length minus 1 minus 1. Sorted nums at sorted nums times length, okay. sorted nums at sorted length minus 1. I'll actually put the parentheses out there. Times, copy this whole thing again, sorted nums 2 minus 1. That was, I mean, I really somehow thought of that question completely differently. We don't need to sort it. We just need the maximum 2 numbers. Yeah, this is right. We can even do better than this. We can do better than this. What's the Okay, so let's make both of them. Let's do let max 1 equals 0, let max 2 equals 0 for const n of nums. If, let's see, if n is greater than max 1, then max 2 equals max 1 and max 1 equals n, else max 2 equals n. And now we should just be able to do return max 1 minus 1 times max 2 minus 1. For 1612, are there any duplicates in here? 3, 4, 5, 2, 1, 5. We can also do greater than or equal to. Let's see if that changes anything. 416. So why is that the case? Max 1, max 2. So if n is greater equal to max 1, max 2 equals 0, max 1 equals 3. If 4 is greater than or equal to 3, max 2 equals 3, max 1 equals 4. 5, 4, and then 2. Max 1 minus 1 times max 2 minus 1. What is the value of console.log? Do I need to be a little more clear here? Greater than or equal to max 2? Do I need to be specific in this? 12, 16, 12. 36.46. By far, this is definitely faster though, because now we went from n log n to linear. So this should definitely be faster. 99.56. Great. Okay, sweet. So this is something new that I'm trying out here. This is going to be my first YouTube live stream. Really happy with this is how this is going, and I hope to broaden my audience through this and sort of like experiment with it. I'm going to leave it like this for now. I'll wrap this up. So if you're interested and you like this content, be sure to subscribe to my channel. Like the videos. It all helps me reach out to a broader audience and help out everyone that's going through their own LeetCode journey. And I hope to see you all very soon. So happy coding and take it easy. Later.